Let's talk about tables. Not that kind of table. The thermodynamic kind of table. Property tables. Today, we're going to cover what property tables are, why they're used, the math you need to use them, and every kind of example you should expect to see. Property tables are sets of material data under different environmental conditions. They're critical in understanding the states a material undergoes during a process. Let's talk about the math you need to know. The quality of a mixture states how saturated a mixture is. If you see a subscript F in the table, that means it's a saturated liquid, or quality equal to 0. If you see a G, it's a saturated vapor, or quality equal to 1. If it's a mixture, the quality will be between 0 and 1. And you can use a formula like this to get the mixture property value. Since the data isn't continuous, we also use linear interpolation to get the intermediate data between table rows when necessary. That sort of math would look something like this, depending on your exact situation. Lastly, there's two forms of property tables, the saturated table and superheated table. You'll use the superheated table if one of these conditions is true. Let's demonstrate these concepts with some examples. Water is a saturated liquid at 4 kPa. What's the enthalpy? Since we're told it's saturated water, we'll use the saturated table. And saturated liquid means that we are after the value with subscript F, or quality equal to 0. Looking at where our pressure row meets with saturated enthalpy, we can find our value. Example 2. Water is at 10 kPa and 200 degrees Celsius, and we want entropy. Looking at our saturation table, our given temperature is larger than our saturated temperature, meaning we'll use the superheated table. 10 kPa is 0.01 MPa, and in this section of the table, at our temperature of 200, we find our entropy value. Example 3. Water is at 850 kPa and a quality of 0.65, and we want the internal energy. Here, we'll use the property formula, and it's good to note that the Fg subscript on the table represents the difference between the F and G property values. So, identifying our values from our given pressure, we can plug in our values and find our internal energy value. Example 4, last one. This time, water is at 215 Celsius and 2000 kPa, and we want the specific volume. Looking at our saturated table at our given temperature, we see our pressure is less than the saturation pressure. So, we'll use the superheated table for 2000 kPa or 2 MPa. Here, our temperature is between the saturation temperature and 225. So, we'll need to interpolate to find our specific volume. The setup in this case is shown with this equation. And when we plug in values to our equation, we can solve for our unknown specific volume. Now, you're a master of property tables, knowing about quality, linear interpolation, and when to use the superheated versus the saturated table. Thank you for watching. Subscribe for more engineering tutorials.